Hello there. Welcome to this short and introductory presentation on API security. The reason why I chose API security topic was twofold. One, the API attacks are becoming complex. Regulators are becoming stringent, asking for inventory and security of APIs. And secondly, a lot of people misunderstand that having an API gateway or even an API security gateway is the silver bullet for all API security issues, which is not the case. So let's get started. API, as we know, are application programming interface that is a collection of communication protocols and subroutines which are used by various programs to communicate amongst them. API or application programming interfaces are key part of the modern web application development. While APIs have been there for more than 2 decades in some or the other form, API security actually is a complex issue, and most of the attacks now are originating and happening in the applications because of the misconfigured APIs. So let's take an example that if you want to apply for a loan. If you want to apply for a loan, your information goes to the CRM and to the loan origination system. Once you provide all the information and upload all the documents, you need to have a credit score. Now, this credit score is being provided by a credit bureau. So when a bank makes an API call, it's a requester, and an API packet goes, which is a HTTP-based request, to the credit bureau, which validates the request, whether it's coming from the right IP address, where the right authentication and authorization is set, and this bank is allowed to access. And there is a unique payload, which is maybe a PAN card number, and a request is that to get the credit score, which then from the application goes all the way to the endpoint, which is a database from where the credit score of the person sought is pulled out, and then a response come back to the bank into their loan origination system. So this is a simple example of an API call. Now, a web API, as we know, is a programmatic interface which consists of one or more publicly exposed endpoint to a defined request and response message system. Typically, it is expressed either in JSON or in XML format, which is exposed via the web, most commonly using an HTTP-based web servers. So if you look at the APIs, there are broadly 4 different types of APIs. The first is the RESTful APIs. This is kind of default or a de facto standard. It dates back to 2000, where the representational data transfer or a state transfer is the most common type of API. Typically, it uses JSON for the data. RESTful APIs are easy to communicate by modern front-end frameworks, which is React and React Native, for an example, and it also facilitates the easy web and mobile application development. As I said, they have become de facto standard for any web API, including those which are being used for business-to-business communication. The second one is the SOAP. SOAP is very legacy, and it uses verbose XML formats for remote procedure calls. It still is found in certain legacy APIs. The third is Graph APIs, GraphQL. It was developed by Facebook, and it's a standard which provides database direct access using a single post endpoint. And it really solves one of the problems that RESTful APIs used to face, having to call multiple APIs to populate a single UI page. Now, the last one is GPRC API, which is developed by Google. It's a high-performance binary protocol. It uses HTTP2 that is largely being used for east-west communication, which is based over the internet, and typically the internal communications are north-south communications. Now, if we look at the API structure and components, most people get confused by what exactly is the meaning of API. But actually, when they are talking about API, they are actually talking about a single API endpoint. APIs sometimes are called as services or API products. They are a collection of endpoints that serves a business function. An endpoint, on the other hand, is a resource, or it can also be a resource path or a URI, which is called as Uniform Resource Identifier, and the operations performed on it. And the operations performed on it can be a create, read, update, or delete. We gave an example of a bank wherein you are fetching the information from the credit bureau, which is a kind of read information, and then when you get, you actually update based on the API response. These operations, which are RESTful APIs, are typically mapped to HTTP methods of post, get, put, and delete. As we said that API security is a complex topic and it requires a comprehensive understanding of various attack vectors and mitigation strategies. Organizations also need to prioritize the security measures to provide API effectively. We can see a lot of common type of attacks. Say, for example, you have client-side threats based on the authentication or using static tokens. You can have protocol vulnerabilities, which can be unencrypted, or how they use APIs. You can have business logic attacks like BOLA, or you can have application attacks like failing to use input validations and allowing the exposure to happen. Now, these attacks can be prevented by using various security techniques. So let's start with authentication and authorization. So this is the first one and the most important, wherein we have to implement a secure authentication and authorization across APIs by using standardized protocols like OAuth2 or JWT token that can help protect APIs from various authentication level attacks. Object level authorization is also crucial for ensuring that only the rightful owner can have access to the data. This prevents unauthorized users from breaching security protocols. Now, the fundamental issue with authentication and authorizations are one, broken authentication and authorization, second, brute force attacks, third, credential stuffing, and maybe the use of stolen authentication tokens. And last can be misconfigurations, which might lead to authentication bypass, either by static token or having some token validation issues. The other part, which is authorization, actually is a very difficult part to get the right. Because one, it has high number of edge cases and conditions, and also because there are various flow API calls between the microservices. So if you don't have some sort of centralized authorization engine, then the API implementation might be including some of the authorization vulnerabilities, such as broken object level authorization or broken function level authorization, as we call it, BOLA and BFLA. The third concept of security is encryption. API security should have encryption for protection of data when they are communicating with each other, which means the data that is being transmitted over the API is secure and it cannot be intercepted by the attackers. Various techniques can be used, like SSL, typically use version 3, TLS 1.3, or AES encryption, which can be used to encrypt API requests and responses and also data at the rest. While there are many possible type of security misconfigurations beyond the authentication and authorization, one of them is insecure communication, which is failure to use SSL or TLS or use some vulnerable old dated, past dated cipher suits. Last one can be unprotected cloud storage and overly permissive cross-origin resource sharing policies. Now let's look at some of the advanced API security measures. The first one, obvious, is input validation, wherein all requests needs to be validated for attacks like SQL injection or command injection, which can bypass authentication or end up giving sensitive information. And also one should do output encoding. The second and important is behavior analytics. Because threat vectors which exploit vulnerabilities either in mobile or web interface, they cost to the user interface to interact with your backend API systems in an unexpected and unsanctioned ways. So the best way to secure backend APIs are abuses is largely because of the behavior analytics. We can create models for baseline usage of backend APIs that will make it possible to detect anomalies and also take proactive steps to secure backend APIs against the attack vectors. Typically, these are not anticipated during the initial development and implementation process and not being driven by a rule-based engine. Hence, we need analytics which can baseline our normal responses of the API and then gives us alerts for any suspicious or out-of-the-way movements. Anomaly detection is again vital for monitoring the API usage. It can identify outliers in the calls, and it can also prevent certain data exfiltration or scraping attempts. This helps safeguard sensitive information effectively. The fourth is schema auditing. It is extremely important because it can help you manage the shadow or inactive APIs. And shadow APIs and APIs which are not inventorized and do not conform to the security standards are a big menace. Hence, ensuring that they are all inventoried, they are known, and they conform to the security standard is important. This control prevents unauthorized access and helps also maintain a secure environment. Now, we will see quickly API gateway. As I mentioned earlier, that most people believe that if we have some sort of API gateway, we are largely secure, but that's not true. While there can be facilities which are being provided by the API gateway of authentication, authorization, and quota management, but API gateways are not sufficient because of two or three broad reasons. One, the discovery of API gateway is having a gap. It has only visibility and control over APIs that they are configured to manage, making them really ineffective at detecting either shadow APIs or the other endpoints. Second is that the API gateways only can enforce authentication and to some degree authorization schemes, but they do not inspect the payloads just like a WAF can do. And they also do not profile user behaviors. Hence, what we need is an API security platform. And API security platforms are available either in SaaS or in in-premise models, wherein they can create a continuously updated SaaS offering. So API security platforms are the best way to really get a comprehensive API security. Largely, they provide 3 or 4 features. One of them is discovery. And the best way to conduct an enterprise-wide shadow API discovery is really to ingest and analyze all API activity log data from the broadest sources that can be done. Second is we can also deploy per app sensor around every API, and that can also provide a rich information about the API activities. But you see, by definition, to provide broad coverage specifically for legacy APIs, we don't really know how many of them are in shadows. So API activity data can be fetched from content delivery networks or API gateways or web application firewalls or Kubernetes container orchestration platforms. Once all of this raw data is available, then AI techniques can be used to transform this into a human readable inventory of all APIs and endpoints and parameters. From there, we can do additional analysis to classify whether these elements in shadow APIs, whether they need to be eliminated or they need to be brought into a formal governance process. Three important points. One, we have to analyze the APIs and their usage in AI and machine learning techniques to discover the business context and also establish the baseline behavior. Second, to detect the anomalies in API usage and when necessary, alert and support the data to a SIM. The third, provide an on-demand access to an API inventory and threat information to both security and non-security stakeholders. As I said, while there are multiple vendors in the market, some of the prominent names are Salt, No Name, which is now acquired by Akamai, Traceable, and App Sentinel. And what they provide holistic discovery, which is providing up-to-date and accurate API discovery or inventory of the API assets, even when the APIs are changing. And discover not just APIs endpoints, but also attributes inside the APIs so that you know whether there are private information or there is a sensitive information like a card, etc., is going into the API. Now, this allows you to apply appropriate security controls to improve your security posture. And you can also control if you want to really allow shadow APIs or block them or forgotten APIs and apply different rate limiting to admin APIs. The second is they provide you runtime protection against business logic attacks because they use numerous AI ML models, and these models are built on deep understanding of the application behavior and monitors the application usage. They understand the context of the application behavior, and hence API security platforms are able to catch and block any adversary activities that may be a blind spot from the current generation of security products. Third and last, they have a rule-based engine just like WAF, and hence they can protect you against OWASP top 10. So with that, I will end my introductory session. In the next session, we are going to bring you a good 30 to 35 minutes training on API security that will be delivered by Puneet, who is the founder of App Sentinel. See you in next video in the next fortnight. Thank you. Have a good day. Don't forget to like, share, and subscribe, and also press the bell icon to stay notified of all the future released videos. See you in the next one. Thank you.